Been working many years professionally in the interface between industry and academia. I'm here to enhance their already high quality research by trying to foster more collaboration among the centers of the BIST, and at the same time discover new ways of doing things. Because we have this multidisciplinary amongst our centers, is that we can cover a lot more aspects of a particular problem. A great example of that is this retina prosthesis. So here's the problem. A healthy retina captures light that represent images. It transforms them into electrical impulses, and those are sent up to our brain interprets them, and I can see you, you can see me. So what happens when you have pathologies that affect the retina? A lot of them affects the first part, the sensing of the light, but it leaves the cells that create the electrical impulses and send them to the brain still able to function. The problem is that we lack the detector in the camera is not functioning. The problem with existing solutions, the electrodes, as tiny as they are, and they're usually made of metal today, they're still far apart. They also dissipate a lot of heat inside your eye. It's not terribly pleasant. It's very rigid, and the eye moves a lot, creating all sort of mechanical problems. The project that's been worked on, it's called Theia, takes advantage of this new technology, this 2D materials, two-dimensional materials that are one atom thick, like graphene, that enable the construction of arrays of electrodes that are very tiny, very thin, so you can pack a lot of them into a very small area. They can be flexible, so they don't have to be rigid. As the eye moves, it can move with the eye, and it can adapt to the variations in the eye. The control, the electronics behind how you deliver, when, and with what amount of energy is what the Institute of High Energy Physics knows how to do, because they do it in telescopes, they do it in satellites. It's their bread and butter. And then the Institute of Photonics are the ones that enable us to use the adequate kind of microscopy to see that everything is working well. Because we're at the stage where we're doing experiments in petri dishes, in vitro, as they're called, and we cannot ask, what sort of image is being created. All we can do is, through microscopy, see that the cells that we're targeting for stimulation are indeed being stimulated. The next step beyond the preparation is to actually implant this on mini pigs, because they're quite similar physiologically to a human eye. Vision is such an important thing. I mean, in everything from intellectual development to economic opportunities. If you don't see well, you have a real big problem.